refresh my mind of, does it say it should be a whole number or? I would probably keep it in a real form up to 1 decimal place. You're talking about the amount of tax which is going to be computed, right? Yeah. Yeah. To be then in that case, let's to stay consistent across the board, as you mentioned, make it to the 2 decimal places, and for the rest of it, whatever it is, let's round it up. Round it up. For our testing purpose, it shouldn't really matter. We can decide one way or the other. Yeah, good. That's a good question. Yeah. What we want to do is basically look at regular rounding rule. If it is 5 or more, go to the next penny. Otherwise, go to the previous one. Yeah, just standard rounding. Any other questions? Okay. Okay, we are going to be talking about the boundary value testing, and most likely we are going to have some time left that I'd like you, well, let's see how it goes. If you have some time left, I would like you to go ahead and apply this one as a team to a project. So killing, two birds with one stone here. So at least you see the application of it to your own project. Even though we are going to do some work as a team in the class, I have some examples here in the book I'd like you to review and basically share that with class. So basically we talked about the function, definition of a function. We can look at a program as a function. Basically you have a set of inputs that are going to produce some outputs, and then you can look at your domain, which is the list of the inputs that you have, and you can focus on the appropriate input data, for example, that you can use to test the program. Later on, you are going to see that we can also look at the range. We can look at the output, and we divide the test cases in such a way that we come up with the appropriate data to address particular range of outputs. But right now, the main focus is going to be what types of input we should have in our test cases. Let's say if you have a function of 2 variables, let's say in this case we have variables x1 and x2. Let's say if x1 has the lower limit of a all the way to b, if you just look at the x1 axis here, that's a lower bound and that's the upper bound that, as you will see later on when we talk about the boundary value testing, it means that our emphasis is going to be on the boundaries. Why do you think we are going to put emphasis on the boundaries in testing? Is what? Yeah, there are many times, as you know, when you write programs, you will see those extremes are the ones which are creating problems, right? Let's say if you have an array, let's say 0 to 100, when you're testing it, you may not even refer to 0 location if the indices are numbered from 0 to 100. Or what would happen if by mistake you refer to a location after the boundary? Your loop, look at the loops that you're writing to find the sum of some numbers. Sometimes you may include the very first number and last number, sometimes you may not, because just a simple mistake on less than or equal. So those boundaries normally create some problems for us, and that's why we want to look at the boundary value testing. So now if you have two variables, two independent variables, so as we mentioned, let's say x1 is from A to B, and let's say x2, C to D, then the values, possible values that you want to use in your test cases are in this area that you have. All the possible combinations of values of A, x1 and x2. Of course, we're going to talk about different types of testing on the boundary. In this case, all you will see is everything included in this box, but you will see that we also address some values outside the box to see for the exceptional situations how the program is going to behave in addition to these valid cases. So as we mentioned, boundary value testing is going to right now focus on the input domain. What's the definition of the domain again, the input domain? There was a very, we looked at the function. Possible values of a variable, input variable is going to be the domain of that variable. And then as I mentioned, as a result of the experiences we have had in testing, those are the boundaries that usually, those extreme values create problems for us. So we are going to focus on these boundaries, mainly on these boundaries to test our program. So there are two, right now, assumptions that we are going to be making. One is whether or not you're concerned with the invalid values. You'll see that we have different types of boundary value testing. Some of them are going to look at the valid values, invalid values, and some of them will not. And also, right now we make the assumption of initially, but later we'll change its assumption. We make the single fault assumption. Some of you may be familiar with the single fault assumption in, let's say, physics, for example, or in reliability theory. What is single fault assumption? Yes. At the same time and break the system. You're absolutely right. So we go with that single fault at this time. So the variations of the boundary value testing we are going to look at are the normal boundary value, robust boundary value, the worst case, and robust worst case boundary value testing. They're very straightforward. Let's say you have a single variable. in the case of boundary value testing, let's say you have, in this particular case, the possible values of x are from A to B. These are the valid values. Now, in the normal boundary value testing, you want to test the minimum, the boundary at the minimum location is referred to as x min. Normally refers to, whether the variable is in parentheses, you specify min. You're going to specify the value at the maximum level, which is x max. Then you go one or the next value basically after the min, so it becomes min plus, could be plus 1, or depending on the range of the values that you have, just the next value up. And with the same token, you're going to take the previous value down from the max. In addition to a norm, normally for the normal value, we'll take something in between. It can be anywhere here, but that's customary that you just take normally the average of these two, whatever falls in between two locations. So your test case, let's say in this case you're going to have 5 test cases to run to see if they work, and we are hoping that's going to catch the problems. Now, what if you have 2 variables? Since we are talking about a single fault, we are saying that it's not possible under the single fault assumption that, for example, x1 and x2 at the same time have their extreme values at the same time. So the way that we can come up with our test cases are, let's say you saw this chart before that, let's say x1 goes from A to B, and let's say x2 C to D. Let's look at the possible values that x1 can take. Just let's look at x1. So for the x2, we are going to take its nominal value. So between C and D, just we take a value that's, let's say, average. We take the average for x2, and then similar to the previous example I gave you, you assign the boundary x min, x max, x min plus, x max minus, and the nominal value for x1. You do the same thing the other way around. You are going to, again, because you want to just change one of them, not both. So for the other one, you take x1 at its nominal value and change the values of x2. So for x2, again, you're going to have x2 max, x2 max minus, x2 nominal value, min, plus, and min. What's the total number of test cases? It is 9, because this is repeated between the two, because we took the nominal value, just the intersected at that point, so you're saving 1 test case. Of course, for real life situations, these things add up. You want to delete as many test cases as possible. If you have any duplications, you want to get rid of them, because they're time consuming. From norm. Yeah. Yeah. Exactly. So, so that's the boundary value testing for a function of 2 variables. What if we have n variables? So we use the same logic to come up with the test cases. Just we want to change one of these variables from min to max. it means the rest of the variables, because that's single fault, are going to hold on to their nominal values. So if you have n variables, you take the very first variable. So second all the way to the end would have nominal values. The first one is going to have mean, mean plus, nominal, max minus, and max. So what would be the total number of test cases in that case? You can, it's a simple computation, you'll find out you're going to have 4n plus 1 unique test cases. Unique test cases. It means if you have any duplicates, we delete those duplicates. Would be good to work on it, make sure that you understand why we are getting 4n plus 1 test cases for this situation. Well, let's see if we can answer this question. Why might this not work? In other words, why it may not catch the possible problems? Yes. That's one. Yes. That's one assumption. What's another assumption that we made that may not in real life work? We made another assumption. It was single fault assumption. But the thing is that if you get away from the single fault, then the combination, some other combinations like both getting their extreme values individually. Look at the simple computation. The simple computation, you're adding two numbers. Adding two numbers, right? If both of these, let's say x and x1 and x2, if you just look at them independently, you're not going to have any problems. What if the maximum value of each of these x1 and x2 separate is going to be the maximum integer supported, if they're integers, supported by your machine? Now, as soon as you add these two up, both of them having their extreme values that we assume they do not, is going to crash. You're not going to have the right result. So now we are making it basically addressing some of these situations that we ignored at the beginning, like for the normal testing, we didn't look at the invalid values. Now we are looking at the invalid values. So in the case of robust boundary value testing, that's the same as the normal boundary value. The only thing you add to it is you go one to the left of the minimum, which is invalid, to see how the system is going to behave. The same way you're going to go one to the right. Just follow the same sequence of steps we have been talking about with one variable, two variables, n variables. See what happens. So basically, one of the things you are going to achieve is by doing this. Okay, how the system is going to respond if I have invalid value? Is it going to crash, or is going to have a very understandable message displayed to user of the problem? Similar to the other one. Now we have two variables. Two variables, single fault. The only difference is what? That you're having these invalid values added to here, but the same logic applies. So these are the test cases you're going to be running, which is what, 7 for 13? We have 13 test cases here. Now we get to the next boundary value testing technique called worst case. That's when you eliminate that assumption of single fault. It means now all my variables can take on all the values. So if you look at that, starting with the so what we are going to be doing is that for, let's say, each value, so far what have we been doing prior to this? We took, let's say, x1 at its nominal value, and x2 went through all its, from min to max. Now in addition to x1 having its nominal value, you're going to go through the cases for every single one when it has its mean value, max value, max minus, and max. Yeah, and max. Yeah. And for each of them, for each of these situations, each of these values of x1, you go through those values of x2. So that should catch a problem like that x1 plus x2 type of problem, if it exists. So that's worst case and robust. It's similar to the previous one, just you're going to pull in the invalid values into the picture as well. You see, they're very similar. The only again difference is that for let's say x1, now you have added max plus and min minus the invalid values to see how the system is going to behave. Let's see if we can think of an example, even though I'm going to ask you to go through some of the examples in the book as well. Can you think of an example of a simple problem that we can use to do some kind of boundary value testing on it? Think of KISS. Keep it simple. Very, very simple problem. The one that we started talking about it, right? So I know that I had I saw some markers somewhere here. Maybe not. Let's say y is equal to x squared. Y is equal to x squared. And x is going to have a value between 10 and 100. Using, let's say, robust, let's start easy first. Using normal boundary value testing. Normal value testing. What are my test cases? How many test cases do I have, first of all? Normal boundary value. Normal, yeah, I changed my mind, yeah. Normal, I thought we start easy and then look at the other one. Sure, sure. So I'm hearing 5 test cases. 3, 5. Who said 3? Why 3? But for the normal, what are we testing? We should test for minimum, maximum, right? Nominal value, min plus, in this case is integer, x plus 1. And so the test cases would be x is equal to 10, 11, 55. Something 55 is in between. 54, 50, again, doesn't matter that much. 50, no, it's kind of in between. And then 99 and 100. If we had, let's go back to that example that you mentioned. Let's see if you have y is equal to x1 x1 plus x2. First of all, what type of boundary value testing should I perform? Let's say again x1 and x2 have the same range from 10 to 100 each of them. What type of boundary value testing you think I should perform on this function? Normal? Since I'm saying 10 to 100. Yeah, normal should do it. Yeah, but if I had given you a larger range, if I had said even the maximum would be something like, let's say it's a 64-bit integer, 64-bit integer we are dealing with. If I had given you a number close to 2 to the power of 60, 60, 61 even, right? Then in that case, what testing should I have done?
Well, actually, even in that case, normal should be fine because you're going to see a clear error.
Oh, am I going to see clear error? What is the clear error?
Clear error is that when you add two integers, it's going to go into a different bit length. So you're going to wind up with that. Like if you add 6 million and 6 million, you're going to get something like 5,000.
You mean wraps around, you mean?
Doesn't make sense because the value that it calculated is too large to fit into that data structure. So you're going to get incorrect output.
Yeah, even the max would give you the problem. Yeah, it means they don't really, even for that case, you don't need to do the maybe robust boundary value testing. Good. Before I talk about the spatial value testing, let's see. What I'd like you to do is, please, as a team, I hope at least one of you is going to have the textbook somehow in some fashion. I'd like you first to read and understand, work as a team. And if your team doesn't have the book, you want to probably join another team. Understand the triangle problem, which is given on page 17. So understand that triangle problem. And then look at the test case on page 85 that I've come up with for this problem, and I like probably a couple of teams come and describe it to the class. So on 17, understand that triangle problem.
Depending on how quick the test cases, how it so for example, so you can put none of them match. So then it goes to the next level. You set if it's true, then you have one match.
Another approach to testing is we call it spatial value testing, which is not really a systematic way of testing the software. It mostly relies on your expertise of working on similar product in the past and use your expertise to come up with the test cases for your product. And basically, at times they refer to it as ad hoc testing as well. The interesting part is that the result has been better than the boundary value testing technique that mechanically we can generate. Actually, there are tools, software tools, that when you tell it, okay, these are the ranges of my input variables, we can generate these test cases that you see on these tables. Is very automated. But in this case, you want to basically rely on your experience and see which part of the system, like we knew when we were rolling out our lottery system, which component we always had problems with when we rolled it out. So as a result, before we rolled it out, we hired quite a few people to train them, so when the clients call in, so they can respond to their problems. But with the components that we did not have that much of a problem, we didn't spend that much money on getting people for the support for the first few weeks especially. So here is an example of using the output as our ranges And then from output, we come back to the set of inputs that we got to use and test the program. In a very high level, I'll talk about it, but again, I'd like you to a little bit read through it. Who has read the commission problem? What the problem is about? Your specific, in order to understand these numbers, we have no other choice but really looking at that commission problem, which is I think on page 26. It's a very short description. Please go through it, and I'd like you to help me out with how we have come up with these numbers on this graph, and how we have come up by looking at this graph, how we can come up with our test cases to this program. So spend a few minutes on understanding that problem, which is on, as I mentioned, on pages 26 through 28. And this one is on page 91, this graph here. So this one is on page 91. And the problem itself, the problem description on pages 26 through 28. It's a very short, again, problem. Now, let's look at the pros and cons of boundary value testing. I mentioned that the advantage of the boundary value testing is really mechanical. You don't have to think about it. You don't have to think about the logic behind it, which is not always working. Remember that we had some situations that were not caught by our by boundary value testing, especially the normal one. So therefore, it's easy to automate. And it's going to be applied on the applications in the areas that you have discrete numbers to work with, the measurements to work with. That you can easily identify the minimum and maximum values in a range. Otherwise, it's going to be very hard. Well, you cannot use the boundary value testing. Disadvantage is that you notice that you may come up with some redundancies. See on that, the very first 15 set of test cases, if you don't pay attention to it, you have redundant test cases which are generated that you don't want them to be there. For large variables, it doesn't scale up as well. And also another problem is that those tools can generate all these input values, but they're not going to be generating respective outputs for you for that program. It doesn't know the logic behind it. Beautiful in testing huge number of test cases. So much about the boundary value testing. And as I mentioned, I think we can really take advantage of the time. I'd like you to start. Let me see. First of all, tell me what you have done so far on your project, what progress you have had, what challenges, if any, you have seen, or any questions you may have. Then I see where we can go from this point. Should I start with the team number 1? Which one is 1? So where are we with the project? with the team project. Okay, so some steps are taken. The repository is there. Okay, team number 2.
We have a repository set up. We actually already have the program up and running and testing. So we're going back and doing the documentation to the steps that we have to do.
Okay, of course, we know that as we cover these, you need to keep on testing the system based. We have already talked about the reviews and inspection. So I hope that if you go with the class, by the time you are done with the main parts of the course, you are done with your project. So far, I was hoping that you would have had some, in general, I'm talking with everybody, to have result on the inspection part.
We're all set. We're about to inspect a written program as well as go through the requirements documentation.
Okay. And then collecting the data and basically presenting it later on. So then we have talked about boundary value testing. Now that's the time to go ahead and start doing that part and document your result. Next time I'm going to talk about partition-based testing, equivalence-based testing that you got to apply. So stay with the class. We don't have that much time. We have about 21 days left. Isn't it that you have to upload your program on the 1st? 21 for the project. Yeah. I know it's hard in the summer. We have long classes and we have long classes, but very short. So that was team number 2. Team number 3. Okay. Yeah, and then please keep in mind you need to do the inspection. You need to have data on that. Ah, okay, yes. Did you check? I have uploaded it there, right? Yeah. Yeah, please make sure that you use the meeting minutes that it's uploaded up there to keep track of the meetings you're holding. And especially there is an area in there, for those of you who had the class with me last term, you remember there is you're counting the number of times that an individual didn't participate. Of course, your meetings could be online, doesn't matter. It doesn't have to be necessarily face-to-face. So keeping track of what happened. It doesn't have to be elaborate. Just one short sentence for each item that you discussed of what happened during the meeting. And keep track of who was there. As you know, we want to make sure the ones who may slack off don't get credit from other team members. You don't want the rest, especially in this short summer, to carry other people's loads. So use that one at each meeting you have, either online, face-to-face, or combination or whatever. Keep track of what happened during that time and take a number of attendance from each participant. Any questions regarding the minutes? Okay, team number 4. You said it's reviewed? So you want to collect the data. That's very important. 5? Let me see. Is it the one that is not attend? Yeah, I noticed that he's not here. So I'm guessing then. Did you send him an email? No response, right? Let's see. Is it? Well, let me see. There was one that I didn't have any. Ah, Reese, William Reese, right? Is it William Reese? Travis. I don't have the group numbers here. I don't know.
Yeah, I thought you were at this group.
So, who was the person again? You don't remember? No, I mean, by looking at the names, would you remember? Oh, okay. But you have sent email, but you haven't received any response, right? But I have all the information online on D12. The group numbers are there, email addresses are there. Please, when you send an email, copy me on that, especially to that individual. Yeah, it is on D12, yeah. But for the email, use the regular email system, especially for me. Okay, so so that you were group 5? Group 5. Group 6? Okay. Okay. And you're the 7th, right? Oh, we have 7. It's group 7. What's the status? Can you speak to number 8 by any chance? Your team? For your team. Well, it's a little bit disappointing. So I'm going to ask a question at least once a week to see how far we are going. You don't have the luxury of time, unfortunately. You got to jump on it and get the thing done. So I would like you not to leave. I'd like you to, as a team, start working on that project for the rest of the time. Of course, if you have any questions, I'll be happy to answer, and then I'll let you loose. If you want to sit here and work on your project, you're welcome to do that. If you're somewhere else, you want to be staying around. Do not leave. It's not the class is not over. I'd like you to please spend the time on your project. Yes.
Exactly. Every type of testing that we discuss in class, you want us to run that on?
Yes. Yeah.
Okay. It was just a little vague on
Yeah, especially that is a good number of members on the team. You should just can divvy it out.
Yeah, I get it.